The name Matlab is a contraction of the term matrix laboratory. Matlab's calling card has always been putting matrices at the front and center of computing. In an earlier video, I said that there's no formal difference in Matlab between an array and a matrix. Informally, we know that linear algebra has rules about how to operate on matrices, and these rules are more complicated than applying the same operator to every element. Let me define a few matrices and vectors to work with. Numbers as scalars. Sometimes these act as one-by-one matrices, but usually they don't. Addition and subtraction of matrices is the same as for arrays, so we just use plus or minus. The star operator by itself without a dot does matrix multiplication. Now, if the first matrix is m by n, this is only defined if the second matrix has n rows. Otherwise, you will get an error. Up to now, I've been using dot quote as the array transpose operator. There is a matrix counterpart to this, which is the quote by itself without the dot. Now, in this case, it did exactly the same transposition to A as the dot quote operator would have done. But in the matrix case, the operator also takes the complex conjugate of every entry. This is usually what you want mathematically if the entries are complex numbers. Continuing on, the caret by itself means to raise a matrix to a scalar power. For a positive integer power, this means repeated matrix multiplication. You cannot raise a matrix to any kind of power other than a scalar. So you see the pattern is that if you use a dotted form of the operator like dot star or dot caret, you get element-wise operation for an array. If you use those operators without the dot, you get these operations in the matrix sense. To close, let me mention the two most fundamental problems of linear algebra. If you haven't seen these ideas before, what follows doesn't make a lot of sense, but you're certain to run into these sooner or later. The first classic problem of linear algebra is the solution of a system of equations. You're given an n by n matrix A and an n by 1 vector B, and asked to find the n by 1 vector x such that A times x equals B. In Matlab, we find x by entering A \B. In Matlab, it's important that you recognize the difference between a forward slash and a backslash. They have related but very different meanings. The second big linear algebra problem is to find the eigenvalues of an n by n matrix. The eig command, eig, takes care of that. That does it for matrix fundamentals. In the next video, I'll talk about extracting and changing individual entries or parts of an array or matrix.